Welcome to myprojectbazaar.com. Let me discuss about the project sensor deployment and scheduling for target coverage problem in wireless sensor networks. Let me discuss about the abstract of the process. A wireless sensor network of spatially distributed autonomous sensors to monitor physical or environmental conditions such as temperature, sound, pressure, etc. and to cooperatively pass their data through the network to a main location. Wireless sensor networks are known to be highly energy constrained, and each network lifetime has been a strong dependence on the node's battery capacity. As such, the network lifetime has been critical concern in WSN research. While numerous energy efficient protocols have been proposed to prolong the network lifetime, various definitions of network lifetime have also been used for different scenarios and protocols. The lifetime of a sensor network is most commonly defined as the time to the first sensor node failure, seemingly over pessimistic in many investigated deployment scenarios. In this project, sensor deployment initially has been done randomly. Here, heuristic artificial bee colony deployment and particle swarm optimization deployment have been proposed. With this algorithm, can able to deploy the sensor and compute the coverage matrix in order to get the maximum upper bound network lifetime. Coverage matrix can be achieved by determining the monitoring of sensors. Finally, obtained sensor nodes are scheduled using a heuristic so as to achieve the theoretical upper bound of network lifetime. This method helps to prolong the network lifetime. A schedule for notification of a sensor rather than disable checking for the sensor altogether. In proposed system, two processes has been performed. One is sensor deployment and sensor scheduling. In sensor deployment, three types of algorithm has been implemented, such as heuristic deployment, ABC deployment, and PSO deployment. In heuristic deployment, initially place the sensor randomly. If the sensor not monitor any target, then move that sensor to least monitor target. Place the sensor at the center of all target it covers in order to cover new target. Finally, calculate the sensor target coverage matrix for estimating the upper bound of network lifetime. In ABC algorithm, initialize the population solution, which is based on the number of sensor nodes. With that population solution, evaluate the fitness function so as to achieve the new solution, which is better than the old solution. Finally, updated the best solution for maximum cycle. In PSO algorithm, initialize particle size and calculate the fitness value for each particles. Find the best fitness value each particle, that is called as local best. Based on the local best, determine the global best value. Finally, update the velocity and new position of the particles. This process will be repeated for maximum iteration. In sensor scheduling, calculate the weight assessment, which is assigned as a battery power for each sensor. Next, cover formation has been computed based on the coverage requirement. Determine the cover set based on the satisfied coverage requirement problem. Let me discuss about the flow diagram for our process. Here, random deployment strategies are estimated based on the heuristic deployment, ABC deployment, and PSO deployment. In heuristic deployment, in this algorithm, initially place the sensor randomly. If any one sensor does not monitor any target, means move that sensor to least monitor target location. Sensor nodes sorted in ascending order of the number of target it covers. Now place each sensor node at the center of all target it covers. While placing that sensor, which should cover one new target, then place that sensor at center, and also compute the sensor target coverage matrix, or else discard that move and place original position. Repeat this process until sensors covers new target. And in the ABC deployment, the ant colony optimization algorithm is a probabilistic technique for solving computational problem, which can be reduced to finding good paths through graphs. Social insect colonies can be considered as dynamical systems, gathering information from environment and adjusting its behavior in accordance to it. While gathering information and adjacent processes, individual insects don't perform all the tasks because of their specialization. Generally, all social insect colonies behave according to their own division labors related to their morphology. Bee system consists of two essential components. If the nectar amount decreases to a low level or exhausted, foregoing bee and abundance of food source and become an unemployed bee. If there are still sufficient amount of nectar in the food source, it can continue to forage. without sharing the food source information with the nest mates, or it can go to the dance area to perform waggle dance for informing the nest mates about the some food source. The probability values of these options highly related to the quality of the food source. And in the PSO deployment, PSO simulates the behaviors of bird flicking. Suppose the following scenario: a group of birds are randomly searching food in an area. There are only one piece of food in the area being searched. All the birds do not know where the food is, but they know how far the food is in each it has achieved so far. Next, in the sensor scheduling phase, here heuristic scheduling algorithm are proposed. Sensor scheduling: in sensor scheduling, weight assessment, cover formation, cover optimization, cover activation, and energy reduction, these processes are carried out. Initially is the K coverage and Q coverage, maximum runtime and priority sensor based on the initial battery power. Initially all sensors having same battery power as 100 units. Check the cover probability. If exists or not. If exists, then calculate cover based on the priority. In the cover formation algorithm, stored sensor in descending order based on the weights. When the battery power reaches E minimum, the node becomes iterative and will not be able to monitor any more targets further. As the battery power is drained, when the node is turned on, the weight assignment by the node to itself reduces. The number of sensors deployed in the area is greater than the optimum number required to monitor the targets. Finally, we achieve the maximum network lifetime and analyze the network lifetime for among three methods. Let me discuss about the running procedure for our process. Select the main file.m file in the current folder, right click that file and run for executing this process. This is the main window of the sensor deployment and scheduling. Here we need to enter the number of sensor nodes to be deployed. And here we need to mention the coverage area, width and height. And here we mention the target. Here we mention 25 as target. Here we need to select the coverage area, that is simple coverage, second for K coverage, third for Q coverage. Here I select the simple coverage. And by pressing the sensor deployment button, here the sensors are deployed, and by pressing the target deployment button, here the targets are deployed randomly. By pressing the random schedule algorithm, we perform the sensor deployment and sensor scheduling network lifetime for random scheduling approach. This will take some time for executing, and here we obtain the network lifetime for random scheduling. After that, by pressing the heuristic deployment button, we move on to the heuristic window. By pressing the heuristic deployment button, we deploy the sensor in a heuristic manner. Here the network lifetime for heuristic achieved, and by pressing the heuristic scheduling, we perform the heuristic scheduling operation. Here the battery power of the sensors are drained out. Based on the battery power, we estimate the heuristic scheduling, and here we achieve the network lifetime of heuristic scheduling. Next, by pressing the ABC deployment button, we perform the ABC algorithm for deployment.